RAM versus ROM. Unraveling the differences in computer memory. Introduction. Computer memory is a critical component of any computing device, and it comes in various forms to serve different purposes. Two fundamental types of memory are RAM, random access memory, and ROM, read-only memory. While they may sound similar, they play distinct roles in the operation of a computer. This article explores the key differences between RAM and ROM, shedding light on their functions and characteristics. RAM, random access memory. 1. Volatility. RAM is a type of volatile memory, which means that it stores data temporarily and loses its contents when the computer is powered off or restarted. This temporary nature allows RAM to be written to and read from at high speeds, making it ideal for holding data that is actively used during the computer's operation. 2. Function. RAM serves as the computer's working memory. It is used to store data that is actively being processed by the CPU, central processing unit, or applications. This includes the operating system, running programs, and data that needs to be accessed quickly for immediate processing. 3. Read/write access. RAM allows both read and write operations. This means that data can be both read from and written to RAM as needed, facilitating dynamic changes in the computer's state. 4. Size and capacity. Computers typically have varying amounts of RAM, ranging from a few gigabytes, GB, in consumer devices to terabytes, TB, in high-end servers. The size of RAM influences a computer's performance, as more RAM allows for the storage of larger datasets and faster data access. 5. Examples. Common types of RAM include DDR, double data rate, RAM, SDRAM, synchronous dynamic RAM, and DDR4, among others. ROM, read-only memory. 1. Non-Volatility. ROM is a type of non-volatile memory, meaning it retains its data even when the computer is powered off. This permanence is achieved through mechanisms like firmware, which is embedded in hardware. 2. Function. ROM is used to store essential software and firmware instructions that are necessary for the computer's boot-up process. It contains information that remains constant over time and is crucial for initializing the hardware and loading the operating system. 3. Read-only access. As the name suggests, ROM is read-only, meaning data cannot be altered or written to it after manufacturing. It can only be read, ensuring that its contents remain stable and secure. 4. Size and capacity. ROM's size is typically smaller than RAM. It holds firmware, BIOS, basic input, output system, and other critical data needed to start the computer. 5. Examples. Common types of ROM include EEPROM, electrically erasable programmable read-only memory, PROM, programmable read-only memory, and flash memory used in devices like USB drives and SSDs. Conclusion. In summary, RAM and ROM are two essential forms of computer memory that serve distinct functions. RAM is a volatile, read-write memory used for temporarily storing data that is actively processed by the computer, while ROM is a non-volatile, read-only memory used for storing critical instructions and software necessary for the computer's boot-up process. Both types of memory are crucial for the seamless operation of computing devices, each serving its unique purpose in the broader architecture of a computer system. Understanding these differences is fundamental to appreciating the role of memory in the digital world.